Do guys learn? Please share your keywords. What did you got yesterday? Some new keywords thing.
So we have learned about Kubernetes orchestration, which is Docker Swarm, Kubernetes. What are the tools we have? We have seen like AKS, GKE, OpenShift, all this.
To run
And we have learned about
containers.
Yeah.
Okay.
To run containers. We have from Docker it is Docker Swarm, and Kubernetes Google from Google it is Kubernetes. Like other tools like AWS AKS and Google GKE, Azure, Azure AKS and AWS is EKS.
Yeah.
Google GKE, OpenShift.
So what is the local tool developers use to test in their local? For example, I wanted to test in my local containers are working or not.
Docker.
Docker and one more I was telling yesterday. That is a new technology, new kind.
Kind.
This is the thing. Whether they are available for Windows or not sure. I was using in Mac only. This thing. Packages, questions, lightning research. Just two, three commands only. Just it will run in your local itself. Kubernetes cluster it will run. And in the Docker desktop also they give this tool. The Docker desktop also nowadays they integrated that Kubernetes also. If you have Docker desktop, automatically Kubernetes will come along with that. So if you go somewhere right here in the settings, you see here this guy Kubernetes. If you check box, so automatically in your lap, if you install Docker desktop itself, you will get the Kubernetes. You no need to install anything. No need to install Kubernetes packages. No, automatically all those will get installed. That you have to do checkbox selected. Otherwise, you can go with the kind tool as well. These two. Yeah, that is local tool. Yeah.
And we have learned about content managed tools like master and worker.
It is.
We have learned about kube config file.
Why do we need kubeconfig?
To log in Kubernetes cluster?
Yeah. Instead of login, you can say that to connect to that. To connect to the KDS cluster. To which component do we interact?
Master.
Yes. Not the worker. We don't work with the master. Worker. This worker interaction will be there with the master. These two will talk. Can I check the logs? You can check logs and all if you want individually, but majority times we talk like 99%. If there is no issues, we don't care about the workers at all. We always talk with master that internally will connect with the worker. Yes, very important file, kubeconfig. How do you get this? There are some commands. If you run that, you will get a kubeconfig in the EKS. You will get automatically. So in the kubeconfig, what content will be there? It's a single file. I was telling yesterday. Yeah. I was telling one. What are the information will be there in the .cube file, config file? Remember, guys. Can you guys tell me what information will be there in the config file? I have updated in the document also. You can access the document. You can go through for 2 minutes. You can tell me what info will be there in the kubeconfig file.
Endpoint M file is.
Okay, endpoint of whom? What endpoint?
Master endpoint.
Master endpoint URL.
Yeah. Endpoint.
kubectl.
Pem file, please.
Sorry.
Pem file.
Yeah.
Pem file, please.
Yeah. Instead of PEM file, right, you can say certificates. Certificates. Yeah. And something user and that user will have a policies, blah blah. Some kind of things will be there here. Yes. Who will authenticate this config file? When what is the command you need to pass to Kubernetes to connect the
kubectl.
master? Kube
CTL.
So where will be this kube config file? What is the default location?
Home directory.
By default. You can change also if you want, but you need to put one more export command then. By default, it's in home directory. So kubectl automatically will go and then we'll load it. It will pass to who will validate config is correct or not. The user is having a permissions or not, all those things.
API trust.
Yeah, where is that API server? It goes to internally, let me tell you, it goes to the master. In the master, we have some more components that we will see. One of the important guy is the API server. This is the guy. This is the guy checks config is correct or not. And then that config is what are the policies it is having. So I was telling it yesterday, IAM is everywhere. In AWS, IAM service is there, but this IAM service is different. This inside this altogether, this is a different concept. You remember I was telling one keyword, RBAC. Role-based.
Rollback.
Yeah, RBAC. Role-based access control. So RBAC. Role-based access control list. It will be there. So whatever there in the IAM, same concepts are there in the Kubernetes also. User will be there, group will be there. You can assign a policies to that user individually. You can assign the permissions. That individual policies you can create. You can assign bind, we call here bind. Everything you can do that. Whatever you're doing in IAM, inside Kubernetes, another an IAM you can create. That is altogether new story. But just I'm telling, this is the crucial guy who will validate your config is correct or not. So when you join a project, what is the tool you need to install in your laptop to interact with Kubernetes?
kubectl.
That is a CLI command to interact. Next, what is the another thing you need?
Kubeconfig.
Kubeconfig. So let's say if I have 10 clusters, 10 Kubernetes clusters also, you can have a single config only. This is single config is YAML. First, it will have a like cluster 1 config, next cluster 2 config, cluster 3 config like this. So you need to set like this kubectl config, something like that. Set. You remember AWS CLI profiles concept. If you have multiple profiles, you need to pass at the end of profile keyword, right? AWS CLI. Same way, like this, you have to set context. I want to connect to the another cluster like this. Then you can run the kubectl commands. I want to change another cluster. Then this is the command. Let's say I need to set up like, for example, one like this. I need to change and then I can run the kubectl command. Otherwise, whatever the commands you are running, they will go to the default one cluster. You can check here where the cluster is there with this command. Sorry, there is a command called get context. This will highlight what is the one currently like this star. It will keep a star, something like this. So what I mean was, if you have multiple Kubernetes clusters, all that cluster config, we have one command. If you run that, it will get appended in this file only. In this file only, it will get appended in this file only, all the clusters. If you want to connect to the specific cluster, you have to run that. This automatically will understand. You don't need to specify anything. This is the command, set context, get context to check. This is how we will switching from one cluster to another cluster. Can I have individual my own config file? Yes, you can have it. By default, it will look for this. Very important things in when I say Kubernetes, please, you have to talk. Just talk. This is the one. What is K8s? What is your thought on K8s?
Container orchestration.
Run the containers.
What is mean by container orchestration?
Maintenance, maintaining,
For
maintaining.
example, for example, like still, what is maintenance meaning?
Application maintenance.
To run the applications like in Docker we have to create image, and in
Uh-huh.
Kubernetes we have to run that image.
Yeah, but still, I'm not getting what is maintenance, what is orchestration. What is your thought? Yes. In Docker also you can do, right? Why you are going for K8s then?
To upgradation or any other things, it is easy to maintain.
Okay. Yeah, that is the EKS part. Then I can go K8s also. Still, we look for a keywords here when you say container orchestration. Anyone talk? You want to talk on this orchestration? Sorry, orchestration. What is K8s in your thought? This this is the like to run that time. These are the questions you'll get it. Let's say in Docker, right? We use individually single nodes and all, but in the Kubernetes we use more than one node. That's the purpose of Kubernetes. If I go with one EC2 mission Kubernetes, that doesn't make sense. Kubernetes is a scalable environment. Scalable. It is scalable. Scalable container. We have in one cluster, I remember how many, like 800, almost 1400 nodes are there in my cluster. In one cluster we are using 1400 EC2 missions we are using minimum, I think. Yeah, 14 plus something. So it's a scalable environment. So now what is K8s in the sense, like to run the containers only, let's say if I deploy container like kind of image, it will run as a pod in one node. If that node goes down, let's say I told 10 pods, for example. So the Kubernetes will manage onto which node it has to go and which node it has to deploy. That management, everything it will take care. In case wherever the 10 pods are running, if those nodes goes down, scheduling those pods, I mean to say running those pods into another nodes, K8s will take care. That is how the management. It is the container pods management technology, which node it has to deploy. In case if that node goes down, how to bring that pod into another node. So something, that's how the management it is that. You have to make some more story on top of what I told the keywords. Pods management. Pods management, I can say that. This, the differences and all. But these are you should have a clarity. Okay. So Docker image, Docker file, that I'm not telling again. Docker build and all. We are purely on the runtime, not the build time. Two things, build time, runtime. We are talking on the runtime thing. So let me tell you, when I say Kubernetes, these are the things you should have in mindset. It's been built on the Go language. Kubernetes on the Go language only. Google company. It's a open source. Kubernetes is open source. It is being taken by the third-party vendors like AWS, Google, Azure, and all. They took outside. They bought their own tools on top of that. AKS, EKS, GKE, something, OpenShift, all this. If you know one, Kubernetes basics, same formula applies everywhere. Everywhere the same concept. What is the concepts? In Kubernetes, you have two architectures, master and worker. To interact with Kubernetes, so we need a kubectl command. You need a kubeconfig file. When you run a kubectl, automatically it will load kubeconfig. It will pass to master. In the master, again we have some components. Whatever I'm telling you, right? This is like theoretically, but in the interview you need mandatory. But in the practically, we don't touch these components majorly because they made a mask. The AWS people and all, they made a mask. They took over all that concepts for you. But in the interview you need. So one of the interview question you will get is, it is architecture. I say that first, it's been segregated to the two parts, master and workers. What is the purpose of workers? Anyone wanted to talk? Why do we use workers?
To run the application.
How do you run the application, the workers? In the workers, what will be running? Applications are other. Do you run application directly on the worker?
No,
No, first
true.
we
Sorry. Please talk. That's okay. Whatever.
Nothing. Images, based on images, we need to run for kubectl.
In the workers, what will be running? That's what my objective. Why do we need workers? What is worker? In your thoughts?
Workers what will be done?
Please go ahead, whether right or wrong. It doesn't matter.
The
Just
bots are running in the worker.
yeah. Pods will be running here. Inside pod, what is running?
Applications.
Inside pod, container will be running. Inside how the container came? Because of image. Inside image, what is there? Application. You remember the image came because of the Docker file, entry point, CMD, those things, right? The keywords, the CMD, where you start application. In the run command, you will install the application. In the CMD or entry point, you start an application. So when you deploy image, the CMD or entry point will start. And then in the Kubernetes, we call as a pod. We don't call directly the container center. Inside the pod, container will be running. Inside one pod, you can have more than one container also. This all will be there. So workers, what is a worker? Worker is the one. Wait. Pod. Running. Yes. Obviously, this is called applications, as I said, applications. So K8s architecture, we don't deploy applications on master. No, we don't deploy. Master is only for to communicate tools. You can use tools also. There are some tools also. We are the DevOps guys. We will have a config file. This config file, we will interact with the master. Master internally interact with the worker. What is a master? You can think master also EC2. What is a worker? Worker is also one EC2. Since we are not in the VM technology, we are using like Kubernetes technology. We bring another keyword here. Worker is another EC2. You can say it's another EC2 only. Master is also another EC2. But we are here, right? Kubernetes, we don't call EC2, we will call here. We don't run any applications on master. We run here the worker. How master worker communication will happen? Specifically, I'm telling interview point of only. We don't break, we don't go there, how it is communicated, we don't check at all, okay? But very important interview question. This is, here you will have one guy called kubelet. Kubelet. Do we install? No. You remember, I was telling you can install K8s and EC2 also. We will install EKS also. What is the best one to go to deliver immediately?
Yes.
EKS, right?
Yeah.
AWS already given some AMIs. What is that? Let me go here. EKS AMI. If you go here, right? They already given some AMIs. You have to use this only, not Amazon Linux and all. No, you cannot use that. You see here, Amazon EKS optimized image. This Amazon built on top of Linux 2 only. This is the base image they took it, okay? And configured some base image for EKS nodes. EKS nodes in the sense worker. The AMI configured to work with some components. What and all they installed? Observe here, please. Kubelet, some authenticator. This is one yesterday we were talking, right? Behind Kubernetes, again, which technology is working?
Docker.
Docker only, behind Kubernetes. And instead of Kubernetes, right, nowadays what we are calling right now is the containerity. These are the tools, already they installed it. So what are the ones? In the AMI, what were there? Can you guys help me? The AMI. One is the Kubelet. And one more is the something I am authenticated.
Authentic.
This is AWS added it. This is the extra flavor they added, AWS IAM Authenticator. And Docker container it's two over there. Now if you take this EC2, right? Hey, I wanted to install an Amazon Linux. What software you need to install here again? This AMI they are coming again. I'll take a vanilla means just Amazon Linux only. What tools I need to install here? In this AMI already they are giving. I'm not taking this AMI. I'll make my own AMI thing. I'll take Amazon Linux only. Then what tools I need to install if I want to set up here?
Docker
Mm-hmm.
and kubectl.
kubectl in your laptop. You getting
Sorry.
you getting my question, right? I will take Amazon
Oh.
Linux EC2. I will make my own cluster. That's what I mean.
Okay. Docker.
Kubelity.
Kubelet. This is the guy. Yes.
Kubelet. Yeah. Kubelet. Yeah.
You need it.
Kubelet.
And one more. I think one more. Did they miss? One more kubeproxy. How it will come? Let me see in the image. Kubeproxy will be there, man. Kubeproxy. Yeah, kubeproxy will be there. These guys brought something up, extra flavor. Let me Docker daemon. I think it will get deployed on the fly. Acha, on the fly we will get. Yeah. Here you need to install one more guy called kubeproxy also. Kubeproxy. Now, this is one EC2 mission. Please tell me now. You need to know this. This is one more. In Kubernetes, one EC2 or more than one EC2?
More than one.
More than one, yes. Let's go here. EC2. Same you will install. Same EC2. So what do you recommend? Next time onwards, I'm getting this requirement. Think that they're not interested in EKS. So they're coming to you every time. Hey, give me one Kubernetes AMI, like Kubernetes installed software. How do you handle it? Yes, one you will take user data, or what is that? Another guy is there, right? The null resource to run the scripts and all you will use it with the Terraform thing. But you have one more, right? Instead of those user data and all, what is the thing you can use? Guys, you know already. One person is coming. I just wanted to give him. I don't want to install on the fly. This is a regular requirement.
Yeah, we have to create an image and then give to them.
Exactly. You will take one Amazon Linux 2 AMI. We will install all these tools. Install. And again, what you have to do? Convert this as custom.
Image.
Create a same. Okay. Now, cool. So this is for whatever you are seeing, right? This is for worker. This is for worker, okay? You have to install manually. Next time, any new kubelet version, kubeproxy version, Docker version changes, right? You have to upgrade. Again, you need to make one more AMI. That AMI you need to use next time, okay? Now, in Kubernetes, you have two flavors, right? What are the two flavors? Two
Master.
master. In master also, you need same. You need this one. And you need to install one more guy, API server.
Sir.
One more you need to install called scheduler.
Scheduler,
etc.
controller, etc.
These are all you need to install manually. Where do I get these softwares? Yes. You have to go here. You have to go. Like we download, Anna, you remember? Elasticsearch. Like for example, the Kibana, Grafana, Prometheus. Like we downloaded a zip files, right? We download individual zip files. Like
Right.
this we have Kubernetes API server download. You go to single page. Here, let's see. This is a single page. You can download kubectl. There is one more. They're giving as a containers also. They're giving a KPI server individual containers also. These are the individual. Now you see right here. You see individually these are the API server something controller manager individual zips. Oh, these are the containers only. API server. You can see here. You can download as a container only. You can download zip also. Individual on the Linux also you can set it up. So this is how you have to install individual all this. This is how you have to individually you need to install this. So what is the best way? Like this or ready-made for me AMI is there. 1, 2. Which one do you prefer?
AMI.
Yes.
AMI, EKS AMI, right? Now, in EKS, what is the one advantage? You already know it. What is the one advantage? In architecture, you have to tell me. One advantage.
So it will manage. It will. We no need to manage master. It will manage by AWS.
Yeah. Master will be handled by AWS, exactly. So what are the softwares are there in the master?
API server, etcd, controllers, schedulers,
One is the API server,
Docker,
one more scheduler,
scheduler,
controller,
controller,
etcd, obviously
etcd,
Docker.
Docker. Docker, kubelet,
One more guy, cube
proxy.
proxy. And yes, this is the basic. And extra something will come here.
Pods.
Exactly. Who will come extra things, guys? Pods. These pods only very important. Inside pod, what will be there?
Containers.
Container.
How container will get created?
Through Docker.
To
Image.
image, Docker image.
Who will pull the image? Where is the image?
Image in ECR or any
Registry.
hub.
Registry. It can be Docker or it can be in the
CR. Yeah.
here.
ECR.
Who will pull the image from here to here? Master or worker? Master doesn't pull any information. Nothing. You have to tell to the master, hey master, give me one node. This is my image. Just give that image name, image URL. To whom? Master. Then master will decide which worker node I need to deploy. That will decide. Then that information, right? That image URL information will be given to worker. Worker is the one who will pull the image. Who is the master? Master just collects information from you. That's it. It will collect from you information like what is the role of master? To whom do we talk to? To whom do we talk to in Kubernetes? Master. The kubectl command will talk. Why do we need to talk? I need to deploy my application. I need to deploy my image. I will say to the master saying that take this image, for example, HTTP image, this tag, maybe ECR URL or Docker up. By default, it will pull the Docker up. Give this information to master. Then master, in the master, how do you give? You need to use this kubectl command. Some command is there, some options. You have to tell, hey, take this image. Then the master, which component will listen your request?
API server.
Exactly, API server. This guy will listen your request. First, when you saying kubectl command, you are passing extra one more guy along with this. What is that guy? Along with this thing, kubectl will be taking one more component to give to API server. One more component.
To config
file. That config file will come to here. It will check. Does this command is eligible to deploy or not? It will check the internally policy also. If yes, API server will decide. Here is the workers. In the worker, what software will be running? Kubelet. Obviously, Docker will be there. Docker.
Proxy, network proxy, kube
proxy. These are the ones, no? 1 second. Even I forgot.
Pods.
Yeah, obviously. Container runtime Docker. Yeah, This kubelet, kubeproxy. Yes, Docker will be running. Yes. Now you gave this information, right? You gave this information saying that I need to run 10 pods, 10 images. No need to do Docker run, Docker run, Docker run. No. Just give this image. There is a keyword called replicas. Say this. That's it. That information, who is collecting now? Who is collecting information? Worker or master?
Master.
It will collect, it will store in this component, etcd. It collects, it stores, collects. It will store. What is the purpose of etcd? It will store all that your cluster information. How many nodes are running, how many pods are running, all that information. Now, you know two things now. API server is the one who will check config is correct or not, all those things. Then it will store in where? API server will store in where?
ETC.
Let me go here. It's paint. I'll go more deep in this guy. This is the master. API server. This is how we will inform to API server. Then API server will store that information in where whatever you had given, it will store here, etcd. etcd is a column database, NoSQL database it is. It will store like this, etcd. Like for example, image name. Then for example, replicas, 10, like this, it will continuously storing column database. What single column only will be there like this, key value, it will store like this. Not like rows. In RDS, right? It's like name, phone number, like something like for example, city, like date of birth, like this, right? This is called row database. You will have a rows, columns individual. But if you go to etcd, right, internally, it is like column. It will be storing like instead of, right, like this, right? All will go like this here. Phone, column database, phone, something. Like it will go in the continuously in one row only, all the data will go here. So why do we use etcd? Whatever you are giving information to master and extra information also about your cluster, all that will get stored in etcd. If etcd goes away, your cluster will get affected. Cluster doesn't have memory. It's like your brain, this guy. etcd is a very important guy. It is been stored all that information. How many applications are running? How many replicas? Like how many nodes are there? Extra information also it will collect. This one. Cool. So in the master, API server will collect, it will store in etcd. Where the application will be deployed? In these two components.
Worker.
Still, master not yet decided that which worker to be deployed, which worker to be, which get selected it. There is a one guy in the master, there is a one guy called a scheduler. This scheduler will decide. Let's say, for example, there are 10 worker nodes are there. 9 workers are very busy. Busy in the sense, there is no CPU, there is no memory, something. It's been very busy. This scheduler has that logic. This scheduler will collect this information internally. They'll talk each together. Scheduler will ask, do you have anything to deploy? Then API server will say that I have gotten deployment. Can you compute? Can you give me which node to select? That information will be done by the API server will ask to scheduler internally. Scheduler is the one will select which node to go. This is the guy. It will select among 10 nodes. This is the node is qualified for this. That is what. Then scheduler will not give to worker directly. Scheduler again will give that logic to API server. API server is the one traffic signal. Everyone will talk to API server only. This guy, everyone. Then API server will get that information. From whom? Scheduler. What is the role of scheduler? Selects the which node. Selects which worker node to get pod. This is the guy. You have 100 EC2 missions. Among 100, it will select one node. Who will select that? It's not one node. It will select based upon your number of pods also. That is very important. So etcd will collect stores. Scheduler will select which node to go. Then again will inform to whom? AP server. All this etcd cannot talk with workers directly. No. Scheduler also cannot talk workers directly. No. Only the guy will talk with workers is the AAP server. Let me show you in the image. You see right here, API server. This is the worker. With this image, to worker, what is the component is interacting with the master? In the
Kubelet.
kubelet. In the master, to which component it is talking? Kubelet.
API server.
These guys cannot talk to this guy. These all guys, right? These all the guys will collect information. Again, will give to whom?
API server.
API server. This API server will pass to whom next? Kubelet. Now you told as an admin, right? I need to deploy an image. API server will check, is this a guy qualified or not? Does config is correct or not? Then it will store that information in where internally? etcd. Then it will ask to whom? Scheduler. What are the nodes are freely available? Then scheduler will give an IP address to API server. Then API server will select that node. It will call that node. In the worker node, you will have a kubeproxy, you will have a Docker, you will have a kubelet. API server only will communicate with kubelet. Now, this is the other flow. Let's go here. Here is the one more thing. Scheduler. There is a bidirectional communication between these guys. They'll be talking continuously. It will be storing, it will be collecting it. Scheduler, oh, sorry. Without scheduler, your nodes will not get scheduled. That is the guide. Now, API server will get this information. It will select to which node. It will select those nodes, worker nodes. So the worker nodes, all they'll talk to, all they'll talk. You know, right? In the worker, they brought one guy called kubelet. Kubelet is the agent. It's agent. You know, right? Node exporter will talk to whom node exporter will talk.
Prometheus.
Exactly. Same model. You think same model. Kubelet. It's agent. This guy is agent. This guy is agent. I'm sorry. Kubelet. This guy also an agent. Now API server will tell that I got an image. Can you take this image? Can you pull the image? Then kubelet, you know, what is the software will run the containers?
Docker.
Exactly. Then kubelet internally will inform to Docker. They'll talk internally. Please, whatever I'm telling, right? We don't interact anything manually. All our automation will happen. But this is the interview they'll expect you. We don't touch anything here manual, anything. Then Docker is the guy who will pull the image from the internet. Let's go here. Let me hide this guy. Now, here is your ECR image. Let me make this one here. Here is the ECR. Sorry. Is content registry. Registry. This is the guy will pull the image. And then once pull the image, automatically they will become as a pods. I mean to say the containers. Pod will come, and then inside the pod, image will get pulled. Inside the pod, container will run. This image will get pulled, automatically run. You don't need to do anything, run, and no need to run kubectl run, sorry, Docker run, no commands. Just give the information to who? API server. Now, few things, master, worker. In the master, API server, the one who will take instructions from you, and then it will store in the etcd. Then it will ask to scheduler which node to select. Then scheduler will select one node. Then API server will reach to that node. But in the worker node, it has to deploy, right? It will talk to kubelet. Kubelet again will inform to Docker. Hey, pull that image. I got an instruction. So kubelet frequently will be talking to kubelet. These guys will be talking to continuously to API server. I am alive. Like I'm live, I'm live, I'm live, like I'm healthy. If this node goes down, right? API server, like it will poll or like vice versa, it will check. Then in case whatever the pods are running, right? These pods will get terminated. This, whatever the number of pods were running, right? That equal number of pods again will get scheduled into another nodes. That API server will take care. Because you told, right? I need to always 10 pods something. That it will take care. Good. So any thoughts you want to ask on it? Any doubts? Who pulls the image? Who pulls the Docker image or ECR image? Who is pulling the Docker image?
Master.
Master doesn't pull image. Master will have your whatever that's the definition. That's it. Who is pulling the image from register? Exactly. Yeah, you can say kubelet or you can say Docker also internally.
Yeah.
Yes.
Yes.
Yes, you can say either one. But kubelet internally will inform to Docker only. Yes. API server will have that info. That's it. There is a one image deployed, and then it went into these nodes. That's it. It doesn't do anything. API server management is the role of API server. Takes info and stores in etcd as a key value pair kind of column. And then in the master, you will have some components, right? Okay, let me put it here. Can you guys talk? Where is this guy? I kept somewhere. What is the role of master? Yeah, this is okay. Let's continue this guy. What did you understand? Please add the points. In master, talk about master.
So in master, we have API server.
It collects the data and stores into etcd.
From where it will collect the data?
From cluster. From cluster info, actually. It's like what are the things we have to run? We wrote in the YAML file, right?
etcd.
No, to store, yes.
It will store
from
into
etcd.
etcd.
But who give that info? Who will give that info? What info?
kubectl.
No.
Yes.
Configuration info.
Okay, who will run kubectl?
Master.
Where is kubectl?
EKS.
Yeah, whatever you are saying, all are correct. I'm just adding some more flavors. That's it. Where is master? Like, what is the concept of master? In Kubernetes, you have two components, master and worker. Now, this is my laptop. Why are we using Kubernetes?
To run containers.
Where it is running? Where it is running?
Okay, EKS.
As EKS. So now EKS, let's say in AWS, two things here. In AWS, you went to like S3, EC2, right? There is a service called EKS. You go and then say that create a cluster. Then it will ask how many worker nodes you need. For example, you will say 10 worker nodes. Automatically 10 EC2 machines will come. You don't need to do anything. Then you will have a one master also. You created a cluster. For this master, you will have a endpoint. Where are you doing all these steps? In your laptop or in the AWS?
AWS.
Now done. Cluster is ready. I want, why did we create this cluster? To deploy applications. To run, what is the input you needed? Image. You need to tell
Right.
that, take this image, run 10 pods something, run 5 pods, run 100 pods. These are EC2. EC2s, okay? EC2, I can say one more, workers. Now, I wanted to connect to this cluster from my laptop or from EC2. Then I need to install a tool called kubectl.
kubectl.
Where is kubectl? What is kubectl? Kubectl is the client. Kubectl is the client command to communicate with EKS cluster. Without kubectl, you cannot connect. Kubectl is outside. This is like in your laptop or EC2 somewhere. Now, we will get one more file. Config file. There is a command called like this. You have to ask EKS, get me the config. You have to run this. And then you have to pass cluster name. This is the command, is the AWS CLI command. You have to run like this from your laptop. If you run this command, automatically in your home directory, one folder will get created. Automatically in this file. In this file, you will have a master endpoint, some secrets, everything will get added automatically. Now you got which file you got now in this? What is the file you got right now here?
Config.
Kube config. Say the kube config. That's the good keyword. Now, you know who will give kubectl? You know where is that? Who will run the kubectl? We are the one. You have to run. You are the DevOps, or you, if you use some automation tools, the tool will run for you. For now, say that DevOps is running this command. Who will run that? DevOps guy. Where is kubectl? Where did we install? In
Laptop.
your laptop, or you can install in the Bastion also something. Okay, now cool. So why are we using run applications? To run. Now cluster is ready, kube config is ready. Now you are able to connect. Now you need to tell to cluster, deploy application. Where is application?
It's in ECR.
It's in
RNA register.
it's in
Register.
image.
Image register.
Where is that image stored? In
Register.
in the you have stored here. It is here now. Cool. Now you have this URL. That's it. Now you will use this command. How to talk to the cluster? This is the command. kubectl. For example, okay. For example, deploy. For example, this image. Like you will say like this. Create a deploy. ECR. HTTPD : one tag --- replicas equal to 100, like 50s. That's it. Behind, what will happen is, behind, when you run this command, this kubectl will load which file?
Kube config.
Where is that? Where is that kube config?
It's in our local .home.
In your home directory, right?
Directory.
In this home directory. In this config file, what is the information is there? Master endpoint, right? Then it will load the kubeconfig file. It will talk to whom?
Master.
This
API.
is the information you are giving. This is the information you are giving. This is the information. What is the information you are saying? Hey, create a deployment by taking this image, run this number of pods. Who will give this info? We are the guys. You have to give this information. Now, you told to whom you are giving that information? Master.
Okay.
This is the info. In the master, who will collect this information?
API server.
Okay.
It will store in where?
ETC.
ETDs.
It will store here. Still image not get pulled. Yes, it took that paper, that's it. It took the paper, one template it took, that's it. Now it is stored here. Now API server will ask to whom internally? It will ask to this guy. It will ask to this guy. I got one image with a replication, 50 pod count, this much CPU and all. Can you give me nodes available for this? It will ask to whom?
Schedule.
Scheduler.
Scheduler.
Then who is talking that? Who is doing that job? Select
API
the node,
server.
API server. But who is the guy selecting the nodes?
Scheduler.
Scheduler.
Then schedule, let's say you have 100 EC2 machines, you will have it. Out of 100, it does some algorithm. What is the algorithm? It will check which is node is free, which is node is healthy, which node is giving me the health check immediately. All that computation scheduler will does. Then it will select because you are giving one pod or 50 pods you are saying it here. 50.
50.
If it is one or it will select a group of nodes. It's up to that. We don't have control on that. Randomly it will select. Either one EC2 or group of EC2 it will select. It will give the IP address to whom? API server.
Okay, sir.
API server will give that info. I'm not telling image yet. That info still. That info will pass to whatever given written by these IPs. It will reach to these IPs. It will give that info file here to this. By taking that info file, this info, where is this? This info, let me go here. It got this info. 1 second. This got this info. This is called info. API server cannot talk to worker directly in the Docker. It cannot talk. It can only talk to this guy. That's how they made it inside that logic kubelet and all. They made it, sorry, kubelet. So API server cannot talk to kubeproxy internally directly. It cannot talk directly to Docker. The only component it will talk directly is the kubelet. Now kubelet got that info. Then kubelet will give that info to whom? To internally Docker. This guy will run these commands, you can think. Docker pull, Docker run, they will take care. This is all masked. You don't care about this guy. Okay. Now, let me ask you a few questions. Who is pulling the Docker image?
Kubelet.
Worker or master?
Worker.
Worker. Inside, if they go more deep, they may ask you like which component, how that knows it, something they may ask it. Okay. Now let's say you deployed now. Again, you run this command. Pods are running. Second time again you ran this command. Second time again. You know, right? Terraform. You know Terraform. You applied first time. There is no code change. You did again second time. What will happen?
It will say there is no changes.
Exactly same. Now you told, right? Already you deployed it. Second time you are giving the same image. Where is this image information stored in the total Kubernetes cluster?
etcd.
That it will compare there. API server will check. I got something. Do you have something similar? Then etcd will check that. Since already it is there, it doesn't do anything. Just it will say that nothing to be changed or something. Now you told something. 1 to 2. Now tell me, what is the process? You told 2. Where this information? Who will collect this information now?
API server will
API
connect.
server.
Okay.
And it will store
It
to
will save
the
on etcd.
Okay, next.
And it will talk to kubelet.
No.
it will
Scheduler, sorry,
Scheduler.
talk to scheduler. Scheduler will tell to API server to which are the pods is available. Then
No, which are the
Kubelet will
nodes?
talk to-
Which are the nodes? Which are the nodes available? Okay.
right.
Yeah. Next.
Yeah,
That
then
is
schedule. Then API server talk to Kubelet and tell to deploy that images into the pods for nodes.
Exactly. Yes. That is how the process will go. This is the deployment process. Not at you end user, not at came here. No. This is the deployment process now. Okay. Cool. Any thoughts you want to ask on it? Now you know the clarity. Why do we need kubectl? I'll write multiple times. Please bear with me. Why do we need kubectl?
To pull the image.
To interact with EKS, maybe whatever
With the
cluster.
cluster. What is the component you are interacting? I'm so
Master.
sorry. I'm so sorry. I'm so sorry. I'm so sorry. I'm so sorry. This guy.
kubectl.
Yeah. That is correct. Kubelet is the one someone was saying, right? To pull that, yes. I was asking, this is the one, my thought. Why do we need a kubectl? To interact with the cluster and to pass info or to collect info. You can get back also. Hey, how many pods are running? I can check like this. I can check this. How many nodes are running? How many deployments are there? For example, like this, you can get blah, 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 multiple things. Where is the
So nodes are nodes are EC2s and pods are containers, right?
Exactly.
Okay.
Inside pods EC2 will be there or inside EC2 pods will be there. Let me put it. Let's make the confusion. Which is correct?
Inside EC2 pods will be running.
Yes, please. You go with 4 years experience. Don't talk this one. Be careful. This is that's why your core basics, right? Inside pods. No, this is wrong. Okay, just a clarity. This is right. Yes, this is correct. Okay. So bring the correct keywords into the table. Cool. Now you are asking to kubectl get to whom this will be talking in the architecture. To whom you are talking in the architecture?
Master.
API server, exactly. From where this in the API server, from where this is collecting the data, from where it will be collecting this data?
ETCD.
ETCD, exactly. ETCD. So it will be talking. How the ETCD will be getting that? Let's say this is what. Let me go. These kubectls, right? They'll be giving continuous information. I'm running this many pods. They'll be giving frequently, like every 15 seconds, there will be heartbeat. Heartbeat will be happen between these API server. They will be giving this information. I'm running this many pods. I'm running this many nodes, blah, blah. They'll be giving it. API server will collect. It will be storing frequently in the etcd also behind. So very important. All these are very important, guys. The whatever we told. There is one more guy, controllers. I'll talk. We'll bring a good situation for that. We will talk. For now, I'm passing it here. I don't want to make confusion here. There is a controller. We will bring a one good context for that. We will talk on it. Okay? Let me ask you now. 1 second. Let me see this. If I ask more deep, more in very, very granular, refiner answer, what is the technology behind Kubernetes? Who is the guy pulling the image? Who is the guy running the image again?
Docker.
Docker only there is it. Docker or nowadays you can call as a container D.
Container D.
That is the guy. What they did, instead of you running manually all these commands, right? They implemented such a way technology. Without Docker, still the Kubernetes cannot exist at all. Okay? Any thoughts you want to ask? Can you guys talk? What is the master components?
API server.
Okay.
ETCD.
Scheduler controller.
There are the controllers. Obviously, Docker will be running here also. Without Docker. Now one more.
Work. Kubelet, Docker, network proxy.
See,
See, one more is that Docker or
Container.
this will be running case. And obviously,
Nodes,
will come
pods.
extra guys. Pods. We will deploy
Pods.
them. We will deploy it. Worker under. This is the architecture of the Kubernetes. So now you know the clarity of the architecture, how the who will talk to whom, what is the command, what is the authentication, how the image will get pulled, who is the guy, that you know the basics at least. Cool. Now tell me, please, this is the guy this is the where the magic will happen in the Kubernetes, okay? I'll go to EC2. We'll come to we'll talk about EC2. We'll come to again to the KTS, okay? I have EC2 running 10.1.0. I'm sorry, let's keep it the public IP 14.4. I'm running one more EC2 where like 50.34.5.6. I'm running one more EC2 here, like for example 78.98.56. All are public IPs. No 10, no 172, and 92. All are public IPs. Okay. Here I'm running Apache. Here I'm running Grafana. Here I'm running, for example, Kibana. Okay. How many EC2 machines? 3 individually. Say that Kibana port number 5601. Yeah, 56. Default. 560. Yes. So Kibana is running Grafana 3000 and Apache, you know the port number. Can you guys tell me? I'm using these two. I wanted to access Grafana. Security group is there, VPC, no issues on that. Okay. Just I want access with the IP address only. Tell me now.
IP address with port number.
First.
Okay.
Yeah. First. Before that, one guy needed.
HTTP.
HTTP.
Exactly. Protocol. HTTP. Please tell me.
50.
IP address.
Tell me now. I told the numbers specific.
50.
Okay.
134.5.6 colon 3000.
Awesome. Perfect. Awesome. This is what I wanted. You know, right? That is how it will go, right? That is how because this has been NIC has been assigned. There is NIC card will be there, Ethernet card. That's how the IP address. Then it will go inside that. Cool. Now I wanted to access Kibana.
Yeah, similarly HTTP colon 78.98.7656.
Okay.
Colon
Cool.
5601.
Awesome. This is how, right? Now 5601 here. Whoever very good in the networking, right? If they don't know Kubernetes, yes, this is how they say. Now let me flip to this is EC2, okay? This is how EC2. 1 second, I'll save that. I'll save it. This is on the VMs technology, if you are in the VMs. Okay, VMs. Same thing, for example, same in the KTS. I'm running in the KTS, okay? Please, this is the one of the most difference, okay? KTS. What are these called in the KTS?
Workers.
Awesome. That is the beauty. Workers. As an end user, right? As an end user, we don't go via master. No. First thing you should know. Don't go via master. Master only for management only. As an end user, my request always will hit worker nodes only, okay? As an end user in the KTS. Access worker node only directly. Okay, that is the one thing. And obviously load balancer will be there because many EC2 missions are there, right? I'm not talking on the load balancer context for now. There is a one myth, you have to break it before it, okay? Now, you know now already. You are accessing Grafana directly, right? in Kubernetes, how it will happen is, let me tell you, please observe. This is the one of the important. For example, okay, for example, I'm telling, for example, please bear with me. 3000. In the VM technology, will it work? I'm asking, with the VM technology, will it work?
No.
Yes.
Yes, it will work.
No, for
So
Apache
you-
3000.
In the VMs.
Yeah, it will work.
Okay. Now,
No.
which IP it will select in these three?
Okay, okay,
Okay,
I
you
didn't see
change
that.
the
Yeah,
IP
it
address.
won't
Okay,
work.
okay. Then it
Say
it
take an
won't work.
Apache, so we need to change the port number. It
It will
Yeah,
fail, right? It will fail, right?
fail. Yes, yeah, it will fail.
But in Kubernetes, it will work.
so irrespective of port number.
No, what happens here is, you are sending request to this guy, right? In this guy.
Yeah.
In this guy, in the worker node, you have one guy called this guy. Kubeproxy.
Right.
This guy will check this. For example, here is also one guy internally. Here also one Kubeproxy will be there. Here also one guy Kubeproxy will be there. This Kubeproxy will internally will check. Where is this my service? I'm giving for example, okay? What you need to know in the VMs, right? We send a directly request to that node only. But in Kubernetes, that will find where in which node that pod is running. That internally will send a request. They'll manage it. Now I'm sending a request to this node, right? Then Kubernetes internally will forward to this node only internally. Who is forwarding? This guy. When you send a request, right? Kubeproxy will accept your request. That internally will forward request to Grafana. They'll manage it here now. That is the myth you have to break now. In a VMs, we hit directly the endpoint. In Kubernetes, I can access like this also. Give me one more example. I can access Grafana with the wrong endpoint. Give me the one more example. Tell me one more example.
560 port number.
You can say like this also.
Yeah. So now also Grafana will it will go to Grafana, right?
Yes. Who is taking care of that job? This guy.
Kubeproxy.
Kubeproxy will take end user request. It will find in the cluster and which node the pod is running. That will forward directly to that. This you know already. This we know from historically our core basics of networking. This you know already. This you know.
So in this case, it won't check the IP address. It will go through the port number only. Like,
exactly.
right?
Yeah. You think
Proxy.
it. Yes.
Yeah.
The Kubeproxy will
doesn't care about the IP address.
Yes, exactly. No request will come to IP.
Yeah.
But you know, right? This guy will accept your connection.
Yeah.
This guy will check it. Where is that port is running? In which node? That internally will direct it. From there, it will collect the information and then it will give the response.
Then why we want to give 3 IP address? We can give 1 IP address.
Yes, you can give. You can give. Just example, I wanted to give that.
Understand.
You can give. You can give 1 IP also. It doesn't matter. So in the Kubernetes world, if you access any one IP, the request will be routed to correct destination, irrespective of the nodes. Who is taking care of that job? Kubeproxy. What is the role of Kubeproxy?
Accept connections from users and route to services. Okay.
That is. Now you know now can you guys tell me the role of worker? What is the role of worker? Worker components. What are the worker components will be there?
We have kubelet, kubeproxy.
What is the role of kubelet? What is the role of kubelet?
It will interact like it will pull the
API server.
and pass info to
Oh,
pods.
Internally to the Docker to do the job. That's it. What is in the worker, right? Who will accept end user connections and all? Qproxy. Let me go to one image. We go to one image. Please, this is in the Kubernetes, right? You access any node, the request will be routed to the correct pod. That's where the networking they break internally. This is the guy is very important guy. You see, right? Users. You are accessing to internally to whom? Qproxy.
proxy.
This has very good intelligence. They'll communicate internally. They'll make their own network. You remember, I was telling overlay to network. If you have multiple nodes and all Docker networking, they will have their own networking concept here. VPC, they'll maintain. We don't touch anything, please. We don't touch anything inside network. But you should know that they form a one network. They have the intelligence where the pod is running. It will route automatically internally. That's it. As an end user, we talk to which guy?
Proxy. Qproxy.
One of the most important interview question, Kubernetes architecture. Remaining all are the deployments related only. You should know the architecture. And one more, in EKS, we don't interact any guy at all. We don't interact, but you should have this core basics. If you are very interesting, it takes time, I'm sure. It takes time, at least a week for you guys. There is a concept called try this if you have interest. Kubernetes in a hard way. There is a one guy, step by step, they'll explain. What they do here, they'll take plain EC2 machines, install individual components. API server, and then the scheduler, and then the controllers, for example, and then the etcd. In the EC2 again, the worker individually install what is that guy? Kubelet. Proxy. Obviously Docker. If you are able to do this lab, I can say that any not interview, I mean any certification you can clear. Kubernetes certifications you can clear. This is hard way. There is a good guy. Let me pull it. Kubernetes hard way. We'll have nowadays like a lot of, this is the guy, the Kensley Hightower guy. This is the step by step they'll give you how to download that individually. You see, right? Services center here. What are the steps? Let me tell you, for Kubernetes, you have very good documentation in the market. You Google it, you will get the best documentations. This is the one way you can try. But we are going this way. EKS. Okay. This is like, it's all up to you. If you have time, please try it. You will have a good YouTube tutorials also on it. But we are going with the EKS route, okay? We're not going with the manual setup on it. But in the industry, right, we don't prefer at all this in the industry. We go, if you are in the cloud, obviously we will go with EKS.
This EKS with any other cloud, this architecture is same, right?
Yes, everywhere you go. You remember this guy, na? This guy. He installed extra this guy.
Okay.
Like every cloud provider, they will install their own extra softwares. That's it. Yes. The architecture, the API server, scheduler, etcd, controller remains same. In the worker kubelet, the Qproxy will remain same everywhere.
And master and worker is common for all.
Yes. But you cannot see the master if you go with the manager.
Okay.
Yes. Everywhere.
It is AKS also same.
Yes. OpenShift also same. Yes. Everywhere is the same thing. You go to Google, you go to OpenShift, you go to anywhere is a common. That's all. So let me pass it here. My thought here. I'll pass it. My objective here you should have is you should have these things in the mind. Why not Docker? Someone can answer. Any thoughts?
Yeah. So if we can run multi containers in Kubernetes, which is difficult and manual work in the Docker.
And then Docker, we can't swap that port numbers like what you can say.
Exactly. Yeah.
Port mapping.
You have to take care of that manual numbers and all, on which node, let's say if that node goes down, you have to do again Docker run in another node.
Yeah.
Here, who will take care of that? The master will take care for you. That node went down. In that node, there were 10 pods were running. Let's bring those extra new 10 pods in the another node. That they'll take care. They'll take care. That's why, right? In the olden days, applications are running in the VMs. If that VM goes down, we used to get phone calls, we used to get night times and all, right? In Kubernetes world, if node goes down, that's okay, let it go down. Automatically, I have extra nodes. The pods will get scheduled there. I don't care. That same pod will come, same image will come. There is no issue in the code. If that image works in my local, that will work in the environment also. Until that code change not happens. Yeah.
Kubernetes, kubectl.
kubectl.
Kubeconfig. Worker.
Exactly. Worker is nothing but another EC2. That's it. Group of EC2. We don't care. It's like in which worker node and all. That's we don't care it. Worker. Who is the how the worker is getting info?
Through API server.
API server.
From API server.
API server.
API server to kubelet. That's one here. Please, I'll pass it here. Tomorrow we will continue. Like tomorrow we will do that. This whatever the cluster setup, right? I will bring up with the Terraform only. The total setup of the EKS. We will bring up with the Terraform. That's my answer. Chalo guys, we'll pass it here.
Thank you.